Welcome to the CompTIA A+ Prepcast presented by baremetalcyber.com. In addition to the foundational devices like routers and switches, modern networks rely on a set of advanced and supporting components that extend functionality, improve control, and enhance security. These include firewalls for traffic control, network interface cards for connectivity, software-defined networking for flexible management, and Power over Ethernet for efficient power delivery. Each of these components contributes to the overall reliability and security of the network. In the CompTIA A+ Core 1 networking domain, technicians are expected to recognize these technologies, understand their roles, and troubleshoot basic issues related to them. A firewall is a security device or software service designed to control network traffic based on defined rules. Firewalls are critical for protecting systems from unauthorized access and are used to filter both inbound and outbound packets. They can be hardware-based, such as an appliance at the network edge, or software-based, running directly on a device. In either case, the goal is the same: inspect traffic and enforce policies that block unwanted connections while allowing legitimate communication to pass. There are two primary types of firewalls that technicians should know: host-based and network-based. A host-based firewall, such as Windows Defender Firewall, runs directly on an individual device and protects only that system. A network-based firewall, often embedded in a router or installed as a standalone appliance, manages traffic between entire networks or subnets. Both types can filter packets using rules and may employ stateful inspection to track connection states, which allows for more intelligent traffic handling. Firewall rule sets are composed of criteria that determine what traffic is allowed or denied. These rules use parameters such as IP addresses, port numbers, and protocols. Order matters. A firewall evaluates each packet against the list of rules from top to bottom and stops processing as soon as a match is found. This is known as first match wins. Misordered rules can unintentionally block valid traffic or allow insecure connections. On the A+ exam, expect to see scenario questions where understanding rule logic is key. In small office and home networks, firewalls are often integrated into consumer-grade routers. These firewalls typically block unsolicited inbound traffic by default, helping to protect devices inside the network from external threats. In some cases, security software suites also include host-based firewall features that monitor outbound application behavior. Configuration is often done through a web-based interface, where users can open or close ports, set traffic rules, and manage connected devices. A network interface card, or NIC, is the hardware component responsible for enabling a device to communicate on a network. Every device that connects to a network, whether wired or wireless, relies on a NIC. Modern desktops and laptops typically have built-in NICs that support Ethernet, Wi-Fi, or both. NICs provide the physical or wireless link between a computer and a network switch, router, or access point, and are necessary for any kind of network participation. NIEs come in both physical and virtual forms. Physical NICs include Ethernet adapters with RJ45 ports and Wi-Fi cards that connect to wireless access points. Virtual NICs exist inside virtual machines or software-based platforms like VPN clients. Even though they're not physical hardware, virtual NICs have unique MAC addresses and can be assigned IP configurations just like physical interfaces. Technicians must understand both types, especially in mixed or virtualized environments. NIC performance is defined in part by its speed and duplex settings. Network interface cards support various speeds such as 10, 100, 1000 megabits per second, or even multi-gigabit rates in modern networks. Duplex settings determine whether data can flow in one direction at a time, half duplex, or both directions simultaneously, full duplex. Most NICs support auto-negotiation, which allows them to automatically match the speed and duplex of the connected switch port, but mismatches can still occur and cause performance issues. Drivers and firmware are essential for NIC functionality. A driver is the software that allows the operating system to communicate with the NIC hardware. Without the correct driver, the NIC may not be recognized or may function poorly. Firmware resides on the NIC itself and controls its low-level operations. Updating either the driver or firmware can resolve connectivity issues, improve stability, or add support for new features. In many cases, network problems stem from outdated or corrupt drivers. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other prepcasts on cybersecurity and more at baremetalcyber.com. Power over Ethernet, or PoE, is a technology that allows Ethernet cables to deliver both power and data to network-connected devices. This eliminates the need for separate power adapters, simplifying the deployment of devices like IP phones, wireless access points, and security cameras. By using a single cable for both power and communication, PoE makes it easier to install devices in locations where traditional electrical outlets may not be available. It also reduces clutter and improves overall network design efficiency. There are two main standards for PoE, IEEE 802.3AF, commonly known as PoE, and IEEE 802.3AT, known as PoE Plus or PoE Plus. The original PoE standard can supply up to 15.4 watts of power per port, which is sufficient for many basic devices. PoE Plus, on the other hand, provides up to 25.5 watts and supports higher-powered equipment such as PTZ cameras or dual-band access points. Selecting the appropriate standard depends on the power needs of the connected device, and is a detail that may appear in exam questions. There are two primary ways to deliver PoE: through a PoE-enabled switch or by using a PoE injector. A PoE switch has built-in support and can deliver power directly through its Ethernet ports. PoE injectors are separate devices placed between a non-PoE switch and the powered device, injecting power into the line without altering the data path. Both methods allow for flexible network design and are often chosen based on budget, port count, and installation complexity. Troubleshooting PoE issues requires attention to both power and data considerations. If a device fails to power on, it may be due to insufficient wattage, incompatible equipment, or cabling issues. Technicians should check the device's power class, ensure proper cabling, usually Cat5e or better, and verify that the switch port is configured to supply PoE. Misconfigured ports or damaged injectors can also prevent power delivery. These types of scenario questions frequently appear on the A+ exam. Software-defined networking, or SDN, represents a shift from traditional hardware-centric network management to software-based control. SDN separates the control plane, the part that decides where data should go, from the data plane, which actually forwards the data. This architecture allows administrators to configure and manage the network centrally, without needing to manually configure each switch or router individually. SDN is especially useful in large-scale enterprise or cloud environments where rapid reconfiguration is necessary. In an SDN environment, the control plane is managed by a centralized controller, which dictates how traffic flows through the network. The data plane, located on the physical switches and routers, simply follows these instructions. This separation allows for real-time, policy-driven automation of network behavior. For example, changes to access policies or routing rules can be pushed to all devices instantly from a central dashboard, reducing errors and saving time in complex environments. One common SDN protocol is OpenFlow, which enables communication between the SDN controller and network devices. OpenFlow allows the controller to dynamically manage routing tables and flow rules on switches and routers. While A+ candidates are not expected to configure SDN systems directly, basic awareness of terms like SDN controller and OpenFlow is required. Understanding these terms helps you recognize modern networking architectures, especially when supporting cloud-based or enterprise environments. SDN contrasts sharply with traditional networking, which requires manual configuration of each network device. In a traditional setup, VLANs, access lists, and routing policies must be programmed into each individual switch or router. SDN centralizes that configuration, providing a programmable interface that can automate updates across the entire network. This not only increases efficiency, but also makes it easier to scale and maintain the network as needs evolve. From a security and monitoring standpoint, SDN offers several advantages. Centralized control allows for consistent policy enforcement, faster response to threats, and easier implementation of access restrictions. SDN controllers can monitor traffic in real time, isolate devices, or redirect flows when suspicious behavior is detected. The visibility into traffic patterns and the ability to rapidly apply changes make SDN an attractive model for organizations focused on security and compliance. To summarize the devices and technologies discussed in this episode: firewalls, network interface cards, software-defined networking, and Power over Ethernet play critical roles in supporting and securing modern networks. Firewalls filter traffic to protect systems, NICs enable connectivity, PoE simplifies installations, and SDN introduces automation and control. These topics are all part of the CompTIA A+ Core 1 exam blueprint and are essential for understanding advanced and supporting network components in a professional IT environment. Thank you for listening. Please visit baremetalcyber.com for more cybersecurity information, podcasts, books, and more.